Process control isn't really too much fun unless you have some disturbances in the process. Most chemical process control is disturbance rejection, that we're trying to mitigate against the effects of disturbances that are coming in. There might be a bit of servo action where we're changing the set points and controllers, but by far the majority of control action is getting rid of disturbances. So how do we deal with this? How do we simulate this in PySim? Really, this is done by some of the simulation configuration. So if we want to set up a disturbance sequence, let's just stop this simulation. If we want to set up a disturbance sequence, the first thing we have to do is go into the configuration menu for the simulation itself. Now, configuration of disturbances and where they appear in the simulation configuration panel is different for different simulations, and there'll be different disturbance variables set up for each simulation. But generally in the sort of disturbance and test variables section of the simulation configuration, the first thing you're going to have is this random seed value. Now this is used to seed the random number generator. If you use the same value of random seed, you will always get the same series of random numbers coming out of the generator. And this is important for disturbance generation because disturbances by their nature occur randomly. So if we set up a disturbance sequence, we're going to have a whole bunch of random numbers being generated. And if we want consistent trials, so if we want to compare one control scheme against another, we have to use the same disturbance sequence to test them fairly. So you would want to be able to use the same random seed value, or if you want to test a thing under another set of disturbances, you might change the random seed value and compare the results with two trials with different random seed values. So in this thing, the two tank level process, the two disturbances that we have are the upstream pressure. So obviously if this upstream pressure increases or decreases, it'll change the pressure drop over the valve, and so it'll change the amount of flow rate that we've actually got going through that valve. And the downstream pressure, which is the pressure down here, if this goes up or down, again it's going to change the pressure drop over this control valve and will change the amount of flow rate. Even if the valve position doesn't change, it will change the amount of flow rate that's actually passing through this valve. So both of these disturbances at the moment in this configuration are set at constant value. The upstream pressure at 1.21 bar absolute, and the downstream pressure at essentially atmospheric pressure in bar absolute. We can change these things to a different unit system if you want, and it automatically changes on the scale there. So if you're not sure what something is in pounds per square inch and you're much more comfortable in that, you can change the thing easily on there. So we can change the disturbance sequence we're using. We can either change it in a single step. If we change it in a single step, it asks you what the initial value is, 1.21, what its final value is, and the number of seconds after the simulation start that the step occurs. So really what we're doing here is just putting a step test into the disturbance and then seeing how the simulation performs. More fun is to actually use the random steps. So what we do on random steps is we start with an initial value. We specify a maximum value that we want that disturbance to go to. So in this case, let's make it 1.3. A minimum value that we wanted to go to. So I don't know, let's make it 1.1. A maximum time between changes. Okay, so the maximum time, let's make it 100 seconds. Minimum time, we don't want to change it any faster than 10 seconds. Now what will happen is a whole bunch of random stuff's going to take place. In time steps between the minimum and maximum, so it could be 30 seconds, 40 seconds, 50 seconds, whatever, but some random number between 10 and 100 seconds, the disturbance value is going to change to some random value between 1.1 and 1.3 bar absolute. The actual value that is determined is just coming straight from the random number generator. So what we'll get is a series of steps of different duration and different size and different direction occurring in the upstream pressure. Okay, so let's just click OK on that one. So we've got random steps It's starting at 1.21. We've got our random seed generator put in there, and let's just zip this simulation for 500 seconds and see what happens. Oh, you can't see an awful lot happening because I forgot to put a tracker on the upstream level. We can see little things happening to this downstream level, but not an awful lot of any great interest. Let's instead put a recorder onto this upstream thing, so let's just configure that to have a recorder on it. We'll just make that a recorder controller if we can find it. Okay. So what this is going to do is just look at the flow rate going through that top valve, make it a wee bit bigger, and let's just stop the simulation and let's just zip it. Let's zip it for a bit longer. Let's make it 1,000 seconds. Okay, so you can see what we've got here then is a whole bunch of flow rate steps, random durations for those steps, and random sizes in those steps. What this does to the simulation really depends on the simulation model. You can see our bottom level here is sort of zooming out slightly, although it's tiny compared to the range, but it's kind of moving about at the bottom. Okay, but that's how you get disturbances into simulation. It has to be programmed in by the simulation designer. If you're producing a user simulation, you can actually set up disturbances as part of the simulation building process in the SimBuilder program, and that will automatically produce a dialogue in the simulation in PySim. Okay, thanks for listening.